going to go our vertical motion. Last time we went our horizontal motion. The differences between horizontal motion and vertical motion: horizontal motion acceleration due to gravity 0, vertical motion acceleration due to gravity negative 9.8 meter per second every second. In the class we are going to use negative 10 because I just don't want to walk around carrying a calculator with me all the time. So we are going to start making connection between what we know and what we want to know. What do we know already? We know the horizontal motion. So let's start with horizontal motion. I'm going to give you 3 scenarios. Scenario number 1, well, let's give you the problem before I give you the scenario. An object is in motion from location A to B to the east. All right. So scenario 1, I'm going to give you just simply a constant acceleration. Constant acceleration. Scenario 2 is just a constant velocity, and scenario 3 I'm going to give you the velocity is 0. So now I want you to do dt, vt and at graph, displacement versus time, velocity versus time, and acceleration versus time. Of course, this is the horizontal motion. So horizontal motion. So acceleration due to gravity is of course 0 meter per second square. No doubt. Okay, so now the second one also dt, vt and at, and then the third one of course the same thing, dt, vt and of course at. All right, now we're going to call this one 1, 2 and 3, graph 1, 2 and 3. Graph 1, 2 and 3. Okay, so every scenario has 3 graphs, dt, vt and at. Now which scenario? Constant acceleration. Which scenario you gonna go? Of course, constant acceleration. Talks about constant acceleration. So let's jump to constant acceleration. Constant acceleration is a horizontal line above the x-axis. Good. Once you have the acceleration versus time, you can go to velocity versus time. If the acceleration versus time is a horizontal above 0, the velocity versus time has to be a diagonal line. If the velocity versus time is a diagonal line, displacement versus time has to be a quadratic. Okay, so far so good. Now constant velocity. Constant velocity directly take us to the scenario or to the graph number 2. So constant velocity, so we are talking about the constant velocity. That's it. So from here we can go to the graph number 3 or graph number 1. If the velocity versus time is a horizontal line above x-axis, the displacement versus time has to be a diagonal line, and acceleration versus time has to be horizontal line 0. Okay. And now the last one is velocity 0. Of course, velocity 0. If velocity is 0, then the at graph has to be of course a horizontal line 0, and dt could be anything, could be horizontal line 0 or could be a straight line, because the slope of this one is 0 and the slope of this one is 0. The slope of this one is a horizontal line, slope of this one is a of course horizontal line 0. The slope of this one is a diagonal line, and the slope of this one is of course a horizontal line. So we double check our math, make sure they make sense. Now we're going to do the vertical motion. So when we talk about vertical motion, we let acceleration is negative 9.8 meter per second square. Of course, in the class we're going to use 10 meter per second square because we rounded it to whole nearest whole number. Okay, so we let an object fall from, let's drop an object from 80 meter above the ground. Okay, so let's do some convention. If anything falling, then it's negative. If anything moving up, then it's positive. Okay, that's the convention. Anything falling, negative. Anything moving up, positive. Okay, so you're going to use this convention to do our math. The gravity is a downward arrow. That's why we call it negative 10. Scenario 1 is displacement versus time. What do you call it? Velocity versus time, and acceleration versus time. And now we're going to do distance versus time, speed versus time, and of course acceleration versus time. Now we're going to fix something. We're not going to vertical velocity acceleration is 9.8 and there is a name for acceleration g for acceleration due to gravity. So we're going to update it. So you're going to write g instead of a, and you're going to write absolute value of g. All right, now we are ready. Okay, so if you drop something from 80 meters above the ground or anything above the ground is a quadratic. Now, right, so what is the slope of this? Fix it. Then it's going to look good. It's going to look better. So the slope of this one is this one. Now, of course, fix this coordinate. Then it's going to look better. How is going to look better? Of course, you're going to find this one, and this is your g. Okay, which you know, -10. Okay, now let's come over here. Absolute value of this one is also quadratic in the first quadrant. Absolute value of this one is the diagonal first quadrant. Absolute value of this is a horizontal above the x-axis in the first quadrant. That's it. All right, good. Now we're going to really do a table. We're going to do time, and then the displacement, and then the distance, and then the velocity, and then the speed, and then the acceleration, and then the acceleration due to gravity. All right, so now how many column we have? 1, 2, 3, 4, 5, 6, and 7. All right, so for the column 2 and 3, we're going to use d is equal to VAT plus half AT square. This formula we're going to use. This comes from a reference table, page number 6. Okay. All right. When you drop an object, because you drop means initial velocity is 0. So make sure you understand that. So now the equation is now easy. T square. Now of course this is a vertical motion. How do you know? I wrote it. Vertical motion. Vertical motion means acceleration due to gravity is a constant. G is -10. No matter you like it or not, doesn't really matter. Okay, so this is 2 and 3, 4 and 5. So you're gonna now write 4 and 5. 4 and 5 we're gonna use VF is equal to VI plus AT. Excellent. When you drop something, initial velocity is 0. So this equation gonna become AT. Now A, of course, acceleration due to gravity. So you instead A, you're gonna write GT. Okay, that's for 4 and 5. Now 6 and 7. 6 and 7 you have acceleration due to gravity is -10. So this is a second degree polynomial, quadratic. This is first degree polynomial, linear, and this is a constant. Okay, good. Now let's do the math. So at 0 second, at 0 second, if you put 0 over here, this is -10. So of course this is -10, and this is t squared. So write t squared. All right. So 0 squared. If you put 0 squared, this one is of course is 0. So you're just gonna put 0. Absolute value of 0 is 0. So now let's do this one. This one is VF. Of course is G is -10. And of course, t is 0, right? So if you put 0. So anything you multiply with 0, you get 0. So speed, absolute value of 0 is 0. Now g, acceleration due to gravity, lots of people think is 0. No, acceleration due to gravity never changes. Whether it's fall, you are running, you are falling, you are sleeping, you are moving, it doesn't matter. Acceleration due to gravity remains same. All right. So now we're going to do the next one. Next one is 1 second. 1 second, if you put 1 over here, what do you get? You get -5. Absolute value of -5 is +5. Velocity, if you put 1 over here, what do you get? -10. And then is absolute value of -10 is 10. And acceleration due to gravity is same all the time. Now 2 seconds. If you put 2 over here, what do you get? You get 20. So -20. And then just 20. If you put 2 over here, what do you get? -20. So 20, -10 and 10. Now 3 seconds. If you put 3 over here, what do you get? 45. Then absolute value of 45 is 45. If you put 3 over here, what do you get? -30, -30, 30. And this is 10, and this is 10. Of course, now 4 seconds. If you put 4 over here, you get exactly 80. So -80, and this is 80. And if you put 4 over here, what do you get? You get -40, and of course 40, and -10, and -10. Okay, great. So this is your table. Now we're gonna get to graph it. So let's to graph it real quickly. So I'm going to do it right here. This would be displacement versus time, this would be velocity versus time, and this would be acceleration versus time. Okay. So this would be displacement versus time, this would be velocity versus time, and this would be acceleration versus time. Okay, let's do it quickly. So let's how many seconds? 4 seconds. 0, 1, 2, 3, and 4. And let's go by 80. So let's go by 20. So 20, 20, 40, 60, and 80. All right. So at 0 second, of course, at 0 second. So this is 0, 0. All right, 0, 0, 0. So the object is right there. Okay, object is right there. All right. So at 1 second, how much object fall? -5. So -5 probably right here, -5. At 2 seconds, how much object fall? -20. So that's exactly 60, right here, 60. At 3 second, object fall how much? 45. So 45 would be what? So 45 would be at 3 second, 45 would be right here, and at 4 second, object right here. So you just I'm gonna connect them. So this is your graph for what? For dt graph. Now velocity, let's do the velocity again. You have 1, 2, 3, and 4. Okay, so you have -10, -20, -30, and of course -40. Okay, so at 0, 0, and then 1, -10, 2, -20, 3, -30, and so on. All right. So the other one is, of course, you have -10. You have 1, 2, 3, 4. Okay. At 1 second is -10. At 0 second -10. 1 second -10. 2 second -10. 3 second -10. 4 second -10. So you just got a constant. Now I'm going to prove that this is actually a quadratic equation. How are we going to prove that? Let's do that. Let's consider 3 points, 0, 0. So 0, 0, and then 1, -5, 1, -5, and of course 2, 20, 2, -20. So this is so yeah. So we're gonna use the quadratic equation. AT square plus BT plus C is equal to P of T. So what is our y? Our y is 0. So T is our y is 0. So T is 0. So T is 0. 0 square plus B 0 plus C. So C is equal to 0. Good. We got the first point. So C is equal to 0. Now step number 2. P of T is equal to AT square plus BT plus C. So now this is your y, -5 is equal to A 1 square plus B 1 plus C is equal to 0. How do you know? C is equal to 0. We already got it. So A plus B is -5. Okay. All right. Now step number 3. Step number 3. P of T is equal to AT square plus BT plus C. All right. P of T is of course -20 is equal to A 2 square plus B 2 plus C is 0. So 4A plus 2B is equal to -20. All right. So then A is equal to, what is it? A is equal to, so we can solve this one. A is equal to minus B minus 5, right? No, A has to be equal to 0. Let me see. This is C. All right. So this is system of equation. Okay. So we're going to do system of equation, not a big deal. So this is equation number 1. This is equation number 2. Okay. So you're going to put equation number 1 under equation number 2. So A plus B, A, so A, so you're going to put A plus B is equal to -5. So multiply this one by -4. All right. So what do you get? You get this one gonna get -4, and this one I'm gonna get -4. So this cancel. So -4 -2b is equal to this one negative, this one this one positive, this one negative, cancel. So b is equal to 0. Okay. All right. So b is equal to 0. So yeah, b is equal to 0. Now what is c? All right. Find a. So a plus b is equal to 0. So -5. So a is equal to -5. All right. Now we almost there. So a t square plus b t plus c is equal to 0. A is equal to -5 t square plus b is equal to 0. 0 t plus c is equal to 0. So negative. So p of t. Okay. So p of t is -5. So now we're gonna write over here. So p of t is equal to -5 t square, and then we can call as d is -5 t square, or d is half gt square, and both are the same. All right, and that was today's lesson.